How's it going, everyone? Welcome. Elvier Gonzalez here. So in today's video, we're gonna explore now of the other layout algorithm, which is position, relative position, and absolute, right? So what I did in the previous video, right, of rendering logic here, which is a course taught by Josh Komua, a software engineer that previously worked at Khan Academy and now, or then at Gatsby, and he made this particularly course where he now is showing is what are the things that are important, what are the fundamentals of CSS, as well as the relevant things that we need to know in today's web development, right? In November 2025. So the point is that because I really want to actually be able to describe this in the most succinct way possible, to make a quick recap of how do we get here. First, in the model 0, Joshua Como actually come up and show all of these different papers as a way of how you can learn, right? It is interesting because a lot of the time, most of us are looking for recipes to do things and so on. But I do really think that the only way that you truly want to know something, if there is a desire to do that, and then you can, of course, is for technical mechanical stuff, you can of course get influence from that. You can actually is get some practical stuff that is gonna allow you to move on in this learning, in this journey, in this learning journey, right? But it's at the end of the day that you have the true and genuine design, that you're sincere with yourself to actually deep dive into this and do that in a systematic way, so you can understand what it's all about, right? So Josh Como actually shows several papers. One of them is the blocking and interleaving. Also, I show off a link from a neurobiology and ophthalmology of Stanford School Medicine, that actually show is how now when you make errors, you are now is reconfiguring is your mind, aka you are now generating is more neuroplasticity. So the errors actually is an invitation for you to understand what the things is all about. So for that, right, when I look at the CSS fundamentals, is to look at the anatomy, similar as the anatomy of a cell. All right, when you have the nucleus, you have the cytoplasm, and you have now the something that I learned yesterday is the in any case, but all the mitochondria and Jesus, cell anatomy, and those machines. So it's a biological machine that live inside of the cytoplasm around the nucleus. That is the ribosomes, and the ribosome is a very interesting machine because now it translates is this single strand RNA into proteins that live in the cytoplasm or the endoplasm. So that's pretty fucked up and interesting. So this is exactly where we're looking at the CSS, right? So what is the anatomy of CSS? So first thing first is that, hey, you can now, so CSS at the end of the day allow you is to define is the layout as of the document by represent each one of those elements as a box. So you have several of this type. So you have several ways to add now styles to your document, whether it's external style sheets, internal or inline. And also you can, another attribute is that you can select elements from the DOMs, so you can apply those CSS rules. So to modify its appearance and layout. So here we have is common selectors, whether it is by class ID, or even the tag itself, or any attributes, or even state based, right? So whether it's hover, or focus, first in child, last in child, so on and so forth. We also look at that CSS provides some behaviors to apply certain rules when that behaviors occurs. So for example, is the media queries, the the media query, the layer, the view transitions. So when a transition happens, this is the set of rules that I want to apply to this particular document. I am not quite familiar with that. That'll be for other videos. Also, we have now functions, which are specific set of tools that CSS provides to run some computations or to do something. So for example, we have is HSL or RGB in the case of the color, or in the case of scaling, right? We can have now scale elements in the X or Z dimension, or even C dimension, okay, among other functions, right? So for example, like calc. Hey, I want to do now some mathematical operations here, some arithmetic here. And also is of course, the box model, the shorthands that we can apply to the box model, whether it's in margin and padding, in the comment, right? This is just the basic anatomy of the CSS. And when we look now, what are the things that are still relevant in 2025, is that media query is one of them. So first is to understand what a CSS rule is, what is the anatomy of a CSS rule, what also is the media queries, why media queries is still relevant in today's modern web development, some couple selectors that are still relevant for us, specifically state-based selectors. So for example, like hover, like focus. What do we care about focus? Because this is something that a lot of the time is helpful for provide accessibility to our applications. We follow is the web content accessibility guidelines to do so, right? So those have certain principles that is say, hey, these elements must be perceivable, must be operable, must be robust, and it must be it must be perceivable, operable, operable, understandable, and robust. It means that your solution must be future proof. And also in their docs actually describe is what are the guidelines when it comes to provide now accessibility for certain elements. So for example, input and focus. All right, when it comes to allow a users without mouse or any pointer device like, right? So to provide accessibility to your app, navigation, for example, across keyword or any assisted technologies, right? So another style base is, so after we look at the focus, we also look at the placeholder as well. The first and end last child, and the first and end of type, all right? And also the after and before for decorations, okay? And then we look at the color formats. So whether it's keyword based like red and blue, to RGB, X, and H, which follow the X code, RGB, and RGB colors, hexadecimal colors, in HSL. And why HSL is much more intuitive, and there also is a particular another format uh, that it makes even more intuitive to figuring out different color nuances. Okay, so HSL, actually I know what it is. I won't dive into that. This is not what we care in today's video. And the other is the type of unit, right, that we can have in CSS that are more common here. So for example, percentage, rem, emd, and pixels, and when we can use each one of them. So for example, we use now rem to referring to fonts. So anytime that the user needs to zoom in the web app for their own visibility, so their fonts will go to now zoom in or zoom out according to that user settings. They can do when they go to the settings here of the browser, right? So when they go to the settings, because I'm working here on Brave, a fork of Chromium, and on appearance, they can actually is on appearance. Well, I am more familiar with yeah, I am more familiar with yeah, I am more familiar with Chrome, for that matter. Yeah, but the point is that in Chrome you have now particular settings that allow you to actually increase or zoom in or zoom out that kind of task, you know. So because of that, right, by the time that I also look at other features, as for example, speaking of the unit, the value unit here that we can have. So we have now percentage, we have now pixels, and we have now root elements. So root elements are most of the time used for fonts. So pixel is when you want to now provide some specific padding and margins to a particular element. Useful if you want to set that into a place. So no matter if the user zoom in or zoom out the fonts, that gap will remain the same. And the other is percentage, which is something that we're going to talk about in the width and height algorithm. Okay, how now this is calculated. The another part of the anatomy is the typography. So we look at what is a sans and serif. Why we have, for example, fonts that are provided usually by Google Web Fonts that comes with multiple character sets that provide, in our case, different font weight and variations. So in the case of Roboto, it brings now 6 font weights in 2 variants. So bold and italic, all right. And also understand that here on CSS, because at the end of the day, you're building products for your applications that you want to provide now a customized experience. So branding, font branding using web fonts is something that allows you to do that. So Google again can provide you several of these fonts. Airbnb give you is this cerulean or this Cyrillian fonts to actually, anytime that you look at that, you say, oh no, this is exactly the font from Airbnb. So this is just part of the branding here. And also is what are the different format or variants that we can have in our fonts. So for example is the bold and what it means, the italic, what it represents. So anytime that you need to describe, for example, content that is on foreign language, you use italic. Content that is from TV show, books, and series, or the title of them, or thoughts that a person might have as well. So we also look at the operation of the text, which is text transformation from uppercase to lowercase and so on and so forth. The line height, all right, the letter spacings, and the text alignment. All of these are just the fundamentals of the 2025 in web development. So, as we now dive deep into what is CSS, and particularly is how now CSS actually renders stuff, which is part of the rendering logic in Model 1, is to first understand is who actually runs that, which is the browser, what the browser has, which is the user style sheets that provide now some default styles of how all of these different HTML elements we're gonna look like. Because before or in the early days of the web, different browsers actually implement their own particularly CSS style sheets, or aka user style sheet, right? So designers back then now develop is this blank state to give now a CSS reset, aka to make all of these elements to work to look like the same regardless of different browsers is. So as the years by, now most of those browsers vendors are now starting to implement all of these features from the CSS the W3C or in the CSS standards, right? So because these particular styles actually, when you develop your applications, some of them are inherent. So for example, most of the time is text-based are inherent, color as well. This particular inheritance might be useful in some cases and might be not. And especially this kind of inherit, which is when you define now selectors, and the pen of the selector that you are using, if they have the same specificity, or in this case, if these selectors are the same based on an algorithm that is computed by the CSS engine, and in this case by the browser, all right? So the way of how this is resolved is by the cascade the cascade. So it's called cascade because it follows certain rules that the further it falls into the cascade, the less likely are to be applied. So this tiers is made of first to understand is the importance of this declaration, whether if you're using a transition or an important key or an opacity as well. The other layer, the other tier is where the CSS styles is located, right? If this is the user font, if this is the based on the web app or the user preference or the browser style sheets. The other is the specificity of the selectors, all right? Whether it's by ID or by class attributes in pseudo classes or by tag and pseudo elements. And last but not least is where the CSS rule is located in that particular style sheet. So the order here matters and where you put it. So you have now two selectors with the same specificity. Well, the last one will be applied, right? I mean, sorry, yeah, exactly. The last one, the first one will be applied. So the further it is on the list, I think it is. I think it is. Mm, 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 mm. Exactly. Actually, it's the last one. Okay. Okay. Yeah, and it matches the intuition here. So the last one will be apply. So why this is important, right? Perhaps you don't need to actually is according to Josh Comer, you don't need to actually remember this and to know what is this and so on and so forth. But I do think that it is still relevant. It is important, especially because as now the demand for people who know what they're doing is important, is vastly, okay, especially when you're doing now some research, which eventually, or some POC, some proof of concept. So eventually you end up doing some of this stuff. So, but in any case, this is now how is this competing CSS are resolved. And then we look now that in part of our content, when we describe content, right, and the way how we read now content, particularly in the Western cultures, we do that from left to right, and top to bottom. So this left to right is known as the inline, which follow is the flow of content, and top to bottom is that when several of these sentence are now stacked next to each other or above another, right? So because this is the way of how we read content in Western cultures, also inspired heavily by the Gutenberg print, and a lot of this stuff that we look in CSS actually come from the print media, all right? It turns out that when you need to serve your content to different other cultures, it doesn't matter, or it doesn't match this way of reading content, way of perceiving content. So, for example, in the case of Middle East cultures, the way of reading is from right to left, and not to mention is the Eastern cultures that are hand-based characters, right? So they're gonna read content from top down, and left, right? So this variation, or this diversity of reading content is what now was the main selling point of having in the language is this inline and block direction contents, especially when you want to now provide is a particular content to move according to the flow of the content, how the content is read, the inline content or the block content, right? So because these contents are now wrapped into a box, which is the way how now CSS, based on native specifications, it transforms each one of those DOM elements to virtual media into boxes, right? That each one of those boxes have now properties and have now layouts that they're gonna behave according to those specific rules, those layout rules. So this box, aka the box model, is made of the content, the padding, the margin, the content, the padding, the border, and the margin. So the content is something that we don't need to talk about that. We know what it is. But the padding is, you can think of this box model as like doing a winter walk, all right? When you put now is your clothes and then some jackets and warmy jacket, all right? So you can think as the content as you are, all right? The other is the padding, that is the fluffy material that separates you from the exterior world. The border is the thin layer that actually cover your jacket, right? And the outside world, which is the margin here. So most of the time we need is at least 2 meters to have now a safe space, right? Or to have a personal space. So as we evaluate is this particular boxes on CSS, which is the padding, and how can we use now padding and the shorthand of using paddings, all right? Some of the tricks in using paddings, all right? And also is with border and what a border needs, what is the anatomy of the border, okay? So it by default needs this particularly this particular border width, all right? This is the only property that it needs to actually be applied. The border width, you can specify is the pixels and the color, and you can also have another property that is outline. This is not part of the box model, but is used for providing now focus to users that may go with assistant technologies, right? So to actually illustrate that, hey, at which element you are currently at. So it actually follows the same format as that. We also looked at we can now provide some round corners to the border. And also is the margin. And how now in the margin we can now is follow the same, it follows the same pattern of the pattern. Margin allow is to now define is negative margins, so we can move this box in different negative positions, right? We can move that box in that particular position. And also it allows is to collapse those margins, which is something that we're gonna see that later. But the way how now these boxes are calculated, the dimension of these boxes, and then the layout is based on the based on an algorithm, where there is the height and the width. No matter which algorithm they are using to calculate is the dimension of these boxes, CSS behave like a set of mini language that now you can is apply different layout algorithms to control how now this box will behave and show, right? Right. So you have now the normal flow, which is something that we're gonna see in today's video, the normal flow, the position absolute, which is also something I'm going to dive deep in today's video, the position algorithm, the relative algorithm, or the relative layout, position and relative layout, as well as the flow layout. We also have now float. We also have now grid. All right. But now understanding that each one of those layout algorithms are provided to us by the language, and this is how now the engine actually is, depend of this specific layout, it have now an anatomy itself. In the case of the flow layout, it is made of the two type of boxes. You have now blocks, inline and inline blocks. So this layout, all right, the flow layout, blocks elements now are greedy. They takes all the horizontal available space. Okay, you can easily resize its dimension, all right, but they don't line break the content. Unlike now inline elements that they only take is they don't want to make a fuss. They only take is the space that is needed, okay, and if there are now overflow that, so they are going to line break that content, especially with text here. There is also some nuance here. So for example, the tags like image, video, and canvas, they are now technically is CSS. They are now inline elements. All right. Despite that you can modify this dimension, but they behave like an inline element. So why this is important? Because for example, when you're using now image and you are putting all of them together, and if you add some space in the markup, they are now adding this magic space. That's one. And the way to remove that is by putting all of these boxes here. All of its markup close to each other. The other is that in image now add this little gap by browsers, and in order to remove that, you can say, hey, let me put this line height to 0. Again, all of these things that I mentioned are specific to the flow layout. All right. And the other is the inline break, inline block. So this inline block internally behaves as a block, but externally as an inline, so it won't break the layout, right? And you can think of this like a lamb in wolf clothing, right? AKA or a sheep in wolf clothing, or a block in inline clothing, all right? And the thing here is that it allows you to modify is the dimension of these boxes, which makes a lot of sense, but it doesn't line break here. So why are we mention this, right? How this type of block actually works and behave? Well, it's because when you need to actually understand how to define the dimension of these boxes in this layout, so the width and the height algorithm, you can break down into two type of values, whether it is the measurement pixels, pixels percentage, rem, right, measurement, or keywords. So for example, feed content, max content, min content. And in the case of the width, right, because these boxes, the way how you can the way how you now use the measurement is pretty straightforward. And in the case of percentage, it is will be calculated based on its pattern with content, right? And when we go to the keywords, which is min content, max content, and fit content, so max content is going to now, instead of looking at the parent containers, is going to look at the children's width. In the case of min context, you're gonna say, hey, I'm gonna look down the children's width elements here, and that'll be now my min width. All right. And in the case of the max content, it say, hey, I'm gonna now calculate is what is the smallest children elements, right? And I'm going to now, in the width, will be now an unbreakable change of all of these elements, right? AKA, with max content, there is no line break, right? And then we have is the fit content. That actually is, well, I'm going to now, my width will be the size of the content, right? So no matter how large this content is, this will be, all right? And when we explore other properties like min height and min width and max width, all right? Also, they have this particular keywords and measurements. So we also explore about how you can now is use these particular values, so the measurements and the position, all right? And as we now explore is the height algorithm, which is behave by default like the min content for the width, which is, hey, instead of looking at the pattern, it's going to, so by default, the height, it is calculated as small as the content to fit in whatever it block is. So this height that actually have is measurements units and keywords. In the case of this is actually quite interesting. This is actually quite interesting because they actually have also is mesh keywords here. You can say fit content, right? And it will be by default is as small as possible here. You can say is max content, right? And again, it's gonna, but the behavior by default, it'll be that. You can also say min content, all right? And no matter which you put here, so the this is something that let's going to explore this, and I do think this is quite important, at least for me. The property defines the height of the content area. Exactly. Anchor size, you have now clamp, right? You have key value here like fit content, outer, and stretch. All right. The browser will calculate and select a height for the specific element, the intrinsic preferred height, the intrinsic minimum height. Yeah, this is also known as intrinsic or extrinsic values. So because now height is by default is based on it based on the content and to be as small as possible, right? Mm-hmm. And they also have now clamp. So you have now anchor size, which are functions here, and also clamp. Mm-hmm. Clamps a value within a range of value between a defined minimum bound and a maximum bound. Mm-hmm. The function takes three parameters: a minimum value, a preferred value, and a maximum allowed. Mm-hmm. Mm-hmm. Clamp, fluid typography. Mm-hmm. Mm-hmm. In SAS. Extending the idea to header with modulo scale. Mm-hmm. Mm-hmm. Anyway, but this is it. Fluid typography here. Mm-hmm. Okay. Mm-hmm. Ah, Amelia Waterbear. Amelia Waterbear has a very interesting video from that, where she talk about is mm-hmm. where she explored what CSS is and so on and so forth. You know. Exactly. Yeah, that's actually the reason why I know about that. All right. So, but in any case, we are not here for this. This is just to explain now how this fluid type is. Um, or aka the font size, where you can always specify is this 3. What a clamp means, right? Clamp meaning fastening tool. A device, a clamp. I don't know how do you say that in Spanish, clamp in Spanish. Una pinza, una abrazadera. Una pinza, una abrazadera, una grapa. Una grapa. Stample. That's different, stamples. Commonly used for paper fastener or stamples. Una grapa. A clamp. Una graspa, una abrazadera. Okay, makes a lot of sense. Again, this is not what we are here, okay? I am just here is because I am describing is, let me put it this way. And just describing is what are the possible values that we can have now here in height, whether it's measurement, all right, root element, pixels, in percentage, all right, and the other are keywords. So when we look at now how this actually behave, the height, it is based by default in it is smallest, the height of any element by default is the smallest possible value to fit that content, all right? So when you now, but it is based on the children, right? So when you're now is looking at the percentage that say, hey, what will be the percentage of if you use now a percentage, right? If you are used to use a percentage, exactly. If you use now a percentage, but I don't think it's working. No, it's not working. If you're using now a percentage here, so if you use now a percentage in an element for mean high or high, and that doesn't work, it's actually kind of weird at the beginning, because as we saw earlier, the default behavior of an element in terms of height is to be as small as possible to contain its children. So because here, in order to actually get the full height of an element, all right, we need to specify that in the root HTML elements along all the possible elements that are until we get into that last element. So this is a way of how you can now pass down is the total height of the container, okay, across your entire different HTML elements. But again, we have to do this. Sometimes we have to do this, and especially if you're working with React applications or Next applications, all right? So sometimes you have to do this. If you want to now is get the height, the 100% height of this, of the viewport. So speaking of the viewport, is that there are now some properties like VH that allow us to do that. But the problem with that is on mobile devices like iOS, Safari, or Android, the VHeight is now taking is the entire viewport, aka because the browser now has an address bar and a footer, so it's actually taking is when the page is loaded, the content is larger than the viewport or the viewable area. So to fix that, you might using is not percentage or this SVG unit, which is a small viewport height. That makes a lot of sense. That makes a lot of sense. That makes a lot of sense. So, and in terms of recreating this, okay, we can now is do some little tricks here, which is say, hey, let me actually is inherit is the full height to all of these elements, all right? And now make this particular element the margin is the margin top outer, right? And now add all of these elements here. So this is not something that we shouldn't be used. This is not recommended, but again, this is also to show that this is possible in order to create this particular layout. And now finally to what we really care in today's video, which is the margin collapse. I do think that as when I did this systematic thinking here, it has served to me well. It is so this devotion to this is what has served me well. Yeah, man. This is the way, man. So now let's talk about is the margin collapse. Okay, earlier we talked about how margin is akin to personal space. And let's suppose that we want us to keep 6 feet of personal space, which is 1.8 meter. Okay, so when we think about it, though, that 6 feet can be shared if each person has a 6-foot bubble, we don't actually need to be 12 feet away, right? So margins aren't overlapping at all. Margins work in similar fashion. Adjacent margin would sometimes collapse and overlaps. So, but this is just describing. Following is the example of personal space, similar with margin collapse. So if we think that, if we think about it, if you imagine that you have now 6 feet, if you have now 6 feet of personal space, you can actually share that space with another person. So we don't have to be is 12 feet away. This is what now margin collapse is, right? Is the idea that two elements now they can share their margins. But this is something that is probably, this now leads to a lot of rules and corner cases to do so. So for example here, okay, the idea is the idea that margins side by side collapse into one space. Is the idea that margins side by side collapse into one space. But this lead us is to a huge myriad of edge cases and corner cases that we're going to develop is an intuition about it.
So margin has this tricky thing that we need to talk about, which is Unlike padding and border, it is possible for margins to overlap. Say you have two paragraphs, right? One on top of the other, and each of those paragraphs wants to have 20 pixels of margin, 20 pixels of space. If you just put them one on top of the other, you're not going to get 40 pixels between them. You're going to get 20 because the two paragraphs are going to share that margin space. And this is called margin collapsing. It's the idea that when you have margins that are side by side, they collapse into one space. And this sounds simple, but there's lots of little conditions and edge cases that make it actually really hard to develop an intuition for if you just wing it. Taking a little bit of time to familiarize yourself with these rules makes things so much easier and so much more intuitive. And so that's what this lesson is about. We're going to develop an intuition for how margins collapse when they do and don't. And just to give you a quick idea as to how this can be surprising and how unintuitive it can be, I want to look at an example. So here I have, it's just a heading and some text sitting in a white box. And you'll notice this heading is right at the top of the box, right? It doesn't have any breathing room. So you might think one way to solve for this is to give this heading a bit of top margin. So I'm selecting just the heading, right? Not the container, but the heading. And I'm going to say margin top. And let's give it 24 pixels. And what you'll notice is it's not moving the heading down. It's moving the entire container. If I look at the container in the DevTools, right?
Exactly.
It still doesn't have any top margin. If I scroll all the way down here, there's no top margin. So it is the margin of this heading which is pushing the whole thing down. And this is weird. We can make this even more noticeable if I increase the size of that margin. Let's bring it up by an order of magnitude. And now you'll see that all of this space isn't getting between the element and its environment. It's transferring up to the parent. This probably doesn't even seem like margin collapse, but it is, and we're going to talk about why that is.
Especially in that particular example.
So 24 pixels.
In that particular example.
And it still doesn't have of the visible if I increase that all of this space.
Right. For example, is this. Where is it? There you go.
Isn't getting.
So the rules of margin collapse. Okay, so what we can say here with the flow layout here, because here we're describing is this, what we can say with the flow layout is, since CSS is made of tiny little programs, okay, since CSS is made of tiny programs, when we need to define how these boxes will behave respect to each other, we found out that there is an algorithm, that there is rules that govern that, aka the layout algorithm, right? Aka the layout algorithm. By default, we have is the normal or flow layout that that is made of two types of blocks, right? Or two type of boxes that is made of three types of boxes, whether it is block, inline, and inline block, right? Block, inline, and inline block, right? And how now they behave, right? So block block takes all the available space, all the available horizontal space, it doesn't line break the content, right? And you can modify its dimensions, so height and width. Okay, so now here in inline elements, it just take the width of the content, so you can modify its dimensions, but it line breaks the content. All right, and this inline block is so it internally behave like a block, externally like an inline, right? Okay. It doesn't line break the content. Exactly. Okay. And then you have now the width algorithm. All right. This is so there are two types of content here, right? So there are two type of um, exactly. So there are two type of so there are two type of exactly. So there are two type of how do you call it, calculation, computation, so on and so forth. So yeah, there are two type of calculations. Yeah, there are two type of calculations. So there are two type of values here. So whether it is measurements, so you have pixels, RAM, percentage, right? And the other is, so this is, and the other is keywords. So feed content, max content, and mean content, right? So why this is important? Why this is important? Because when you want to determine the width of an element using percentage, this is calculated based on the pattern content. Okay, so by default the width is calculated based on the parent element. Okay, so for example, if you now, and this is true because if you now have a particular element here, so for example like this box, right? And if you want to now add some additional elements here, let's say, hey, I just want to edit the HTML here, which is, let me add this another element here and say if now figure, right? And this figure is, hey, this one, right? Or you can say it's another one. Right, and here we say, so what is my width, right? And if you do that, as you can see, we add that element and say, hey, what is my width? So now, because this particular element doesn't have that, and here we add now is the height from this. But this is exactly, this is the height, all right? But the width of this element, right? So the width of this element is outer, aka it means that is that, right? So this is what it is with the width. So the width, when there is no attribute attached to, it will look up to the tree, right? Okay, so by default, the width is calculated based on the pattern elements. Okay, when you don't pass any, when you don't exactly, when you don't set a specific width. All right. For example, 150 pixels. All right. So this is what it is. In keywords like feed content, max content, and mean content, all of this is put it here. All right. So in there you go. So values like mean content, max content, and feed contents, each one of them look at the look for the children to calculate the look at the children to compute their width. All right. So the keyword here, so this will look, so all of the keyword, so the following keywords are except author. Exactly. So the following keywords, mean content, max content, and feed content, the following keywords, mean, max, and feed content, all of them look up for the, so look up, so all of them calculate the width based on its children elements. In the case of mean content, is by looking at the widest children element, and that will be the mean width, and that will be the width, right? The other is so this looks up at the max, this look up at the minimal or at the smallest element width of, exactly, this lookups of the smallest element width and change the content, and change the content to calculate in so this lookup of the smallest element width of unbroken change, right? So the content is so the content won't line break, but it is useful for small content. And this will look up so it will compute the width to match the content width, right? This is all about is the width algorithm followed by the keywords, and also is the height algorithm, right? So in the case of the height, here is this. So again, height by default behave like mean content. It takes it is value is based on the smallest so its value is based on the smallest in the smallest size to fit the content. But it is based on the smallest children size to fit the content. Children element size, or child exactly, is based on this. Its value is based on the smallest child elements size to fit content, right? So we get this. Okay. Okay. So we got this. Okay. So one funny thing, or not that funny, okay? So when we use, for example, percentage, one funny and not that funny things that happen is that is not taking the full height as we expected, because, and we can use now that particular example here of the height, right? It won't take that. For example, like this. So for example, this, right? Mm-hmm. For example, here, section is okay. Section is asking So section is trying to set the height. So section is trying to set the exactly section is trying to set the mean height based on its paragraph exactly since our section sits inside the body tag because of this. Our section sits inside the body tag, so when we set the percentage base height or mean height, the percentage is based on that pattern height. Body doesn't have any specific height set, which means it uses the default behavior and stays short as possible, while still containing all of its children. So it means, in other words, we have an impossible condition here. And this is a really common source of confusion. It isn't fixed by Flexbar or Gris either. Those tools help us control the content of a container, but the container still needs to get its height from somewhere. And to fix this, we have now this. Exactly. So the way to solve this is now being explicit about that, right? Being very explicit about it. Being very explicit about it. You can fix this is with that. Mm-hmm. And the app wrapper gotchas. The app wrapper gotchas. And what about VI unit here? And how to explain that kind of stuff. So the rules of margin collapse. Okay, this is the rules. Only vertical margin collapse. To really understand margin collapse, we need to consider a lot of different circumstances. Let's go through them one by one, looking at how different situations lead to different results. This can be a lot of to take in. In the very next lesson, in the game testing you on these concepts, you may wish to bounce between the two, go over a couple rules, and try the games and rinse and repeats. Which is part of the rules here. And this is something that can take. This can be a lot to take in, and this can take a lot to take in here. So only vertical margins collapse. Only vertical margins collapse. Okay. When margin collapse was added to the CSS specification, the language designers made a curious choice. Horizontal margin shouldn't collapse. In the early days, CSS wasn't intended to be used for layout. The people writing the spec were imagining headings and paragraph. Headings and paragraph, not columns and sidebars. So that's our first rules. Only vertical margins collapse. Okay. In the early days, they didn't intend to use the layout for that, and the people writing the spec were imagining headings and paragraph, not columns and sidebars. That's our first rules. Only vertical margins collapse. Only vertical margins collapse. Exactly. Only vertical margins collapse. So for example, like this. Unless you change the writing mode. So if you change the writing mode, of course. Only vertical margins collapse. Okay. Only vertical margins collapse. You can see here in this writing mode, vertical left to right. Only block direction margins collapse. Blocks direction. Only blocks direction margin collapse. Only block directions margins collapse. Vertical text on the web is relatively rare, even among website reading in hand-based language that is historically written top-down. It is important to recognize that English is not a universal language of the web, but almost all web language are written either from left to right or right to left. Margins only collapse in flow layout. So margins only collapse in flow layouts. Is unique to flow layout. If you have children inside display flex parents, those children's margin will never collapse. Only adjacent elements collapse. Only adjacent elements collapse. So the BR tag invisible and empty, but on any elements between the two others will block margin from collapsing. The bigger margins wins. The bigger margins wins. The bigger margins wins when they collapse. Nesting doesn't prevent collapsing. Nesting elements. Margins will always try to increase distance between siblings, even if it means transferring margins to the pattern. Block by padding or border. Block by a gap. As we saw in high algorithm, a pattern will vacuum seal child around a child. A 150 pixels tall single child will have a 150 pattern tall with no pixels to spare on either side. But what if we explicitly give our padding elements a height? Well, that could create a gap underneath the child. The empty space between the two margins stops them from collapsing, like a moth filled with hungry piranhas. Note that this is on per side basis. In this example, the child top margin could still collapse and blocked by a scroll container. Later in this course, we'll learn how the overflow property can create a scroll container. If the padding elements create a scroll container with a declaration like overflow auto or overflow hidden, it will disable margin collapse if the margins are on the either side or the scroll container. Here's the takeaway from this 3 scenario. Margin must be touching in order for them to collapse. Margins can collapse in the same directions. Nesting doesn't prevent collapsing. Nesting doesn't prevent collapsing. Blocked by padding or border. Blocked by a gap. Margins can collapse in the same direction. More than 2 margins can collapse. and negative margins. As we saw when we look at margins, a negative margin will pull an element in the opposite directions, a sibling with negative margin top. How do we negative margin collapse? Well, it is actually quite similar to, to positive one. The negative margin will share a space, and side of that space is determined by the most significant negative margin. So with margins, the greater one collapse. Negative margins. Margin top minus 2050, margins for 50. So they don't collapse. They collapse is when they have negative margins. The smallest one will be. It's like they added together. Mm-hmm. Okay. Multiple positive and negative margins. And negative margins here. And negative margins here. And this is part of the game, and using margin effectively. So the other is, will it collapse? So a game is to make it this interactive, bro. And the other is now this, using margin effectively. Margin is like a glue. It's really like quote by Hayden Pickering. Margin is like putting glue on something before you decide what to stick to, or if you should be stuck to anything. I try to avoid putting margins on something at the component boundary. So for example, let's say we have a video clip component like this. So it's like putting as a glue where you want to put it here. So you might be imagining embedding this video in a blog post where the margin is 32 in all directions, right? And you know you will want to get some space, right? But applying margin in this way is gluing the component without knowing where you'll stick it. So I have this component, but I don't know where I'm gonna stick this. You might be saying, but no, I know where I want to stick in the blog post, and that's fine for bespoke one-off component. A video clip sounds generic and reusable. I might want to use it in a lot of different places, and those places might have different spacings requirement. And those spaces might have different spacement requirements, bro. Spacing requirement. For reusable components, we want them to be as unopinionated as possible. Because next week, you may want to create a video strip component that lines up several clips without any gap. And now you have a problem, because the same component needs different amounts of margin in different situations. There are a couple of solutions to this. One is allow the components like video clip to accept class name props so that we can supply the correct amount of margins whenever we use this component, and we'll talk about this strategy in Model 3. And another option is to use layout components. These are components that are intended to wrap around an element to provide some of the sort of shared layout. For example, the Bright Design system has a stack component. Has a stack component that apply vertical spacing between its children. Hey, I want to apply vertical spacing to this component. Okay. And this is part of this 6 jobs wireframes, thus a pack. And why is this? Why is the motivation of this? Welcome to Braid, the themable design system for the SIG group. Braid aims to make cross-brand UI development as fast as possible. Okay, UI development as fast as possible while maintaining high level of quality and accessibility. In order to achieve this, Braid provides a set of React components and CSS variables based style using vanilla. But again, it's based on this. A market leader in its online employment marketplace, SIG has been helping people live more fulfilling and productive working life and helping organize success over 25 years. Overseas, SIG is this. SIG operate market leading online employment marketplace in Australia, New Zealand, Hong Kong, Indonesia, Malaysia, Singapore, and Thailand. Founded in Melbourne, Australia in 1997, SIG has grown into a multinational technology company with over 3,000 employees and is listed on the Australian Security Exchange. 1997, SIG found in Melbourne, SIG.com.io, and seed growth. And then in 2006, SIG's first international investment in Xiaoping, expansion and international growth. In 2006, 9 years later, SIG's first investment in Javascript and Brazil Online. SIG's first invest in JobsG and OCC. Product and technology evolution. JobStreet and JobC joins to form SIG Asia. Creation of SIG investment, acquire 100% of SIG Asia. Corporate restructure, including corporate restructure. They lay off a lot of people, including creation of the SIG Growth Fund, Sheldon and Xiaoping. Rollout of unified product and technology platform across APAC. Sale of Latin American assets. Unified platform for future growth. This is the first time I hear about this. Online education. SIG Growth Fund. Alura, Coursera, Manifest, OS, Util, Florence, Higher Up, Job and Talent, Workana. And even Workana here. Contingent labor. Xiaoping. Non-controlling investment. Xiaoping and others. Core APAC. Expanding sourcing solutions and other business. In the newsroom. Sustainability, social impact, data cybersecurity, responsible AI, and about SIG. This is the first time I hear about this. Board and executive. Yeah, this is the first time I hear about them. Group Executive, People and Culture, Chief Financial Officer, Lisa Tobin, Group Executive Technology, Peter Beatos, Simon Luces. Yeah, this is the first time I hear about this. Anyway, okay. Mm-hmm. Braid Design System. Braid aims to make cross-brand UI development as fast as possible. But Braids provide a set of React component and CSS variable base styling themes using vanilla extract. What makes Braid different as much as possible, we want Braid code to make sense to non-developers. We aggressively focus on the simplicity and composability of its API. Along with our work and playground, our goal is to empower designers and developers to iterate together in the same medium using the same component. Mm-hmm. First, we recommend reading the design workflow and the development workflow guides. These capture our current vision of how best to make use Braid in daily work. The design workflow. How do I leverage Braid in my design process? What is Playground and why I should use it? It's like a okay. It's how now this content should be look like. And fit to window. Mm-hmm. Or wireframes. Okay, for rapid prototyping here. Uh-huh. Mm-hmm. For rapid prototyping here. Okay, based on their own things, bro. Okay. So this is how it's going to look like in different places. And they're going to expose is their own components here. Exactly. And they're going to expose is their own components to that. All of them. Mm-hmm. Mm-hmm. Okay. You can add this, and there's another element, but this is for rapid prototyping here. That's interesting. Okay, for rapid prototyping here. Brands aims to make cross-brand UI development as fast as possible while maintaining high level of quality and accessibility here. Okay, hey, this is how it's going to look like here. Mm-hmm. Okay. Mm-hmm. All right, and if you want to, for example, add some element here, right? Not sure if they're going to render that. It's a style. And say now padding. Say padding for a 100 element. All right, to apply that. But this is for rapid prototyping. That is very interesting. And it is also collaborative. For rapid prototyping and collaborative. Okay. For rapid prototyping and collaborative tools. Okay. All right. Exactly. And they're going to render that as it is. That's interesting. That's a very powerful stuff here. That's a very powerful stuff here. For rapid prototyping as well. It's saying it doesn't accept that, but this accept this. Okay. Use margins effectively. Okay. That's quite interesting. That's very interesting. That's very, very interesting. So in any case, that'll be all for this video. Take care. Bye bye.